So we're going to be graphing sine and cosine functions here. So for section 4, we're going to go through it in detail, and then you're going to use a lot of, or everything that you learn here in graphing the other functions in the other sections. Okay, so let's take a look at a sine graph here, down here. You see this is a sine graph, all right? And the first thing, what's the first thing that comes to mind? What's it remind you of? It looks like a what? Or a wave, right? It looks like a wave. That's what it is. It's all waves can be modeled by sine or cosine graphs, right? So it does look like a wave. Now, looking at this graph, and it continues on either end, what would the domain be here? All real numbers, right? But look at the range. What do you notice about the range? It goes from what to what? Y equals -1 to 1. So it just oscillates, that's the word. It just oscillates or bounces back and forth between -1 and 1. Okay? And, okay. Now, take a look here for a minute. If we start at x equals 0, right? X equals 0. At x equals 0, that's where the graph is, right? And at x equals 0, what's the y value? 0. That's important. Okay? From that, okay, it goes up to the maximum, then to 0, then to the minimum, then back to 0. Okay, so it goes up to 0, down to 0, up to 0, down to 0, okay? Now, this is one cycle, and you see how it goes it goes back to where it started, right? And so now when the next curve starts again, all it is a repetition of this green one that I've highlighted. We call this one cycle, okay? And then it repeats over and over and over and over again. Now, how long does it take for one cycle to complete? It starts at x equals 0. It ends at 2 pi. Because it takes an interval of 2 pi for it to complete one cycle, we say the period is 2 pi. Okay? Questions? Okay. So the period is the time it takes for it to complete one cycle. All right. Now, so let's go through some of the other details here. So this is 0, this is pi here. So what's this red point here? Pi over 2. That's 1 pi. And then here, this is 1.5 pi, 3 pi over 2. Okay? So, at pi over 2, what's the y value? At pi over 2, what's the y value? 1. Positive 1 at pi over 2. So this is sine of x. At pi over 2, the y value is 1, right? Now, question for you. Let's go back here for a minute. Remember when we did quadrantal angles? Yes. What was the sine of pi over 2? 1. Right? You see that? Do you remember that? What was the sine at 3 pi over 2? What's the sine at 3 pi over 2 here? What's the sine value? It's y over r, -1 over 1, -1. So going back here, what's the y value at 3 pi over 2? -1. At pi over 2, the sine is 1. At 3 pi over 2, the sine is negative 1. It's the same thing as on the unit circle.
By sine, do you mean?
The sine value, like S-I-N-E.
Okay.
Yes, I know. It's unfortunate. I always say one of the words
Sine,
has to...
like S-I-G-N?
No, S-I-N-E.
Oh.
Like
cosine.
Like sine, cosine.
Okay.
One of those has to change. It's unfortunate that S-I-N-E and S-I-G-N sound the same. See, in Greek, it's like sinus.
Sigma?
Oh, yeah, signa. Yeah. In Greek, it's like sinus and cosinus. So they're, But anyways, okay. So now, what you have to remember is the following. Sine of x at x equals 0 starts on the x-axis, then it goes to the maximum, back to the axis, minimum, back to the axis. This is all you need to remember. The most important is that for sine of x, it starts on the axis at x equals 0. Okay, now look at cosine. At first glance, it doesn't look different at all, right? What's the only difference?
So, like, is at 0, and it equals 0, y is at 0.
Right. Okay? If this sine graph was movable, and if I grabbed onto it, and I just pulled it to the left a little bit, so that the top here aligned with the 1, would it look just like that? It would. And that's what they are.
They're all the same.
They're the same exact thing. It's sine and cosine graphs are the same exact thing, except one is shifted to the right by a little bit. Okay, so that means the domain is all reals, and the range is still negative 1 to 1. It just oscillates between negative 1 and 1. Okay, so let's take a look. The one cycle or one period of the cosine starts here, goes down and up, and ends here. That's one cycle, that's one period, we say, of the cosine. Again, it takes an interval of 2 pi to complete. The difference is the following. At x equals 0, it starts from the maximum. Then again, it just oscillates. So it can't go further up because it's got to oscillate around the axis. It goes to 0. Now it's got to go down, back to 0, back to the maximum. Okay? Okay. Now, so the period, again, okay, so the period of the sine and cosine is 2 pi. So they repeat at every interval of 2 pi. Because of that, they're called periodic functions. Because they repeat at regular intervals, they're called periodic functions. Why is it called the periodic table of elements? Because every time you go over 8 elements, you go back to an alkali metal, right? And then an alkaline earth, right? They have the same characteristics, yes? Then you go over another 8. It repeats at regular intervals. That's why it's called the periodic table of elements. When you get a magazine that's published regularly, it's called a periodical. You see the, right? Okay. So as we mentioned, if you take the sine and shift it over, it becomes a cosine graph. So all graphs that are basically shifts of sine graphs are called sinusoids. Okay, so a sinusoidal graph or a sinusoidal function is basically, it's a function that is based on a sine. Huh? Oh, yes. Okay, here's the general form of sine cosine functions. This is what they look like. Okay, in that mess, you have a sine, okay, y equals sine of x. Then you've got your embellishments, a, b, c, d. These are constant. Every single one has its own function. It has its own purpose. I don't want to use the word function. Okay? All right. So what we're going to do is we're going to go through A, then B, then C, then D. Okay? Let's start with A. A provides a vertical dilation. It basically tells you how tall the graph is. If the absolute value of A is greater than 1, it's an expansion. If the absolute value of A is less than 1, it's a compression. When it comes to sine cosine functions, we don't call it like a dilation. We call that the amplitude. Okay? All right. The amplitude of a sinusoidal function is how high or low it goes from the axis of oscillation. So if this is your curve, at the very center is your axis of oscillation. What can I? Okay, so that's the axis of oscillation. How high it goes from that, so how high the peak is, or how low the valley is, they're the same distance, that's A. Okay? So if A is 1, it goes up to 1. If A is 2, it goes up to 2. Okay, so let's graph a couple here. All right. So I have f of x and and g of x, sine of x and 3 sine of x, right? Okay. How are they related? So basically, you see how g has a change in A? It's got a different amplitude, okay? All right. So it says find the amplitude of g of x. The amplitude of g of x is just 3. So you just say 3. That's it, nothing else. Now, I'm going to show you guys how to graph this. So here's what you're going to do. For these, I'm going to give you a blank grid like this. I want you to put in the horizontal x-axis. All right, and here's what you're going to do. On your x-axis, you're going to make 5 tick marks. 1, 2, 3, 4, 5. Okay, I'm skipping a box just so it doesn't get too crowded. It's up to you. Okay, what's the period of the sine function? 0 to 2 pi. So I go 0 to 2 pi. What's the point dead center? Pi. What's that first corner or quarter? Pi over 2, and then 3 pi over 2. Okay. Now, the y-axis would go here. Right? Okay. Now, first I'm going to graph f of x. Sine of x starts on the axis. Okay? And we'll say this is 1 and negative 1. Please label that. So now you have 5 points. These are the 5 critical points. You're going to put 5 points on your graph. So what did we say the sine does? Goes from the axis, maximum 0, minimum 0. So at pi over 2 maximum, then 0, then minimum, then 0. There you go. Connect it. And there. Your very first sine of x graph. And of course, we're going to label this f of x.
How do you know to only go up 1?
Because there is a coefficient of 1 here.
Okay.
So now we're going to graph g of x. G of x is still a sine x graph, same amplitude. But now, okay, I start at the 0, but at the maximum, I'm going to go up to 3, 0, minimum, 0. Look at that. It is absolutely beautiful. Okay? And that is g of x. Okay, What do you need for your graphs to get full credit? You must label 5 points on the x-axis with the correct calibrate, like with the correct values. Label the y-axis so I know you're going up by 1s or 2s or whatever. And then, you know, it has to be a correct graph, obviously, right? Okay. Now, what if you have a reflection around the axis, the horizontal axis? Look at F and look at G. What do you notice about G? There's a different coefficient and there's a negative, right?
Yeah.
So what's the amplitude of G of x? Okay,
2, because it's got absolute values.
just 2 because it's just the distance. The negative is a reflection. Okay, so for this one too, I'm going to graph both F and G, and then we're just going to graph G for the most part. Let me do this in black. Okay, so again, 0, 1, 2, 3, 4, 2 pi, pi, pi over 2, 3 pi over 2. Okay? All right. Now, this is where the y-axis would be. Okay, this is a cosine. This is 1 and negative 1. So for the cosine, I start at the maximum, right? Then I go to 0, minimum. Oh no.
So, we're good.
You're getting a little too aggressive there with the graph.
Yeah, I'm so excited.
It is exciting. It is. So, okay. So here we go. One thing. This is not a V. Not an absolute value graph. So what I do to help me is, remember this curve is going to like continue as a wave on the left side. So, you know, make a little curve there and make it go down. You know, give it that nice little curve. Okay? You will get better at that. Just don't make them like, you know, corners. Okay. Now, that's f of x. Okay. G of x has an amplitude of 2, so it goes away. So it goes 2 away from the axis. But because it's a negative, rather than starting at 2, it's now going to start at negative 2 right here. And then from there, where is it going to go? Up or down? Up to the axis, right? It can't go further down. You can't get away, like further away from the axis. Up, axis, here. So it's always minimum 0, maximum 0, right? Like it goes away and back, away and back, away and back. And then again, a cute little curve. Oh my! Look at that G of x. Okay? So do you see the difference?
Oh, so okay.
Yeah. Good question, yes.
Oh no, I
That's a little bit.
Okay,
That's all you need to do. There's no other like answer.
that's it. So now,
Wait.
okay, so what's the difference? Okay, why are X-rays so dangerous, whereas light, which is the same sort of wave, is not as dangerous? Why? Because of the frequency. Because if, you know, one wave behaves like that, an X-ray would behave like this, right? So the period here is much longer and the period here is much shorter. Okay? So, yep. So now, not all waves then, not all graphs are going to have the same period. To find the period of a specific function, the formula is 2 pi over b, right? And b is, you know, like the b in this function, b. Okay? So now, for example, suppose y equals 3 sine 5x. The period is 2 pi over that number 5. Okay? 2 pi over 5. So, when the period is modified, we're going to take the term bx plus c and make an inequality out of it. The inequality is going to look like that. Okay? What do I mean by that? Well, I'll tell you what I mean by that. Okay, so here, look at these two functions. What's the amplitude of g of x? The amplitude? 1. The amplitude is 1. It's that number. Okay, and what's the period of g of x? The period is 2 pi over what? A half, which is 4 pi. Okay, so now, let's forget about that for a minute. Okay, so here's my x-axis, right? So now that the period is 4 pi, it's gonna, go over an interval of 4 pi. So basically when that happens, the start or the end or both are gonna be changed. So to figure out where your graph starts and where it ends, you do 0 less than or equal to this half x, and then less than or equal to 2 pi. Okay? It's always from 0 to 2 pi because that's what the original was. Okay, so now let's solve for x. We remember how to do that from algebra, right? Multiply everything by 2. So I get 0, x, 4 pi. That means here I'm going to start from 0, 1, 2, 3, 4, go to 4 pi. What's the middle? Dead center? 2 pi. First quarter? Pi, and then 3 pi. Okay, now, so the y-axis goes here. Now look at f of x, cosine, right? Cosine would have started at 0 and ended at 2 pi, right? So cosine would have looked like this. It's 1. This is what cosine would have looked like, right? Starts at 0, goes to 2 pi, yeah? But now, what happens with the other one? Now it's going to go all the way to 4 pi. So now I have to have my 5 critical points. So we're going to start here. The next one is pi, then 2 pi, then 3 pi, then, 3 pi is on the 0, then 4 pi. So, okay. I'm not gonna ask you on the homework or on the quiz to draw both on the same graph. I only did it here to show you the difference. Do you see how it takes much longer to complete? It's a slower wave. Okay? Any questions? Okay, so what is this then? When you do this, this will give you the beginning, and this will give you the end of the cycle for g of x. And the balance from 0 to 4 pi, that distance is 4 pi. It has to match with the period. So for these, it's like, duh, Miss Malikan, the period's 4 pi. It's going to start at 0, go to 4 pi. But not all the time. Okay? All right. Frequency. I'm just going to tell you what frequency is and then skip example 4 because I kind of don't feel like doing it this year. And it's fine. Okay, so the frequency, okay, is the reciprocal of the period. Okay, so what was the period? The period was how long does it take to complete a wave? The frequency is if you were standing, right, looking down and like the waves are passing by you. If you time the waves, how many waves will pass by you in a second? That's the frequency. Okay, so how fast they're coming at you. Well, if you're at the beach, okay, like one peak and another peak, then another peak, right? Okay. So frequency is 1 over the period, which is b over 2 pi. So for example, if y equals sine, I don't know, 3x, then what's the period? 2 pi over what? Period, 2 pi over 3. And the frequency, 3 over 2 pi. You should know that. Okay? I'm going to skip that lesson. I mean, that question. Okay, phase shift. Phase shift is a horizontal translation. But in the world of trig, we don't call it a horizontal translation. We call it a phase shift. Okay. You know how you get phase shift? Very simple. Basically. Remember that term bx plus c? Right? A equals, y equals a sine bx plus c. You solve the equation bx plus c equal to 0. So let's solve this for x. Subtract c from both sides. Bx is negative c. X is negative c over b. That's how you get phase shift. I don't want you to memorize that because it's 2 pi over b, and then there's like this. All I want you to know is 2 pi over b. Please don't memorize this. I only did this because students ask me, Miss Malikan, where did they get this from? I just want you to see that it's the same. To solve for the phase shift, I just want you to do this every time. Okay? Okay. So, let's do one. It's exciting. Look at this function. Look at this. 2 sine 5x plus 5 over 4. Did you ever think you would be able to graph something like that by hand? No. But look at that. Here we are. Okay. All right. What's the amplitude of that function? 2.
Yes.
Yes. So you need to know that stuff like boom, 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 right? These are like the freebie points here now. Okay. Period. 2 pi over 5 says Mayan. Is she right?
Yeah.
Yep. Okay. Frequency is what? 5 over 2 pi. Okay. Common mistake. Often, students will get the period right. They'll get the period right. And then they either don't, they forget what to do for the frequency. You just have to turn it around. Just get the reciprocal. Or they'll write this, 5 over 2 pi. That's no good, right? It's not 5 over 2 times pi. It's 5 over 2 pi. So please, please, please make sure that pi is nice and tucked in under that denominator. No ambiguity. Okay. Phase shift. This is the most important part of the function. Okay? That's that like beefy part, like it's the filling of that donut, right? So you take the 5x plus pi over 4, set it equal to 0, and solve for x. So 5x is negative pi over 4. Now, I'm going to divide by 5 on both sides. Dividing by 5 is the same as multiplying 1 over 5, right? Thank you for agreeing with me. So now x is negative pi over 20. What does that mean? That means this graph has been shifted negative to the left by pi over 20 units. Okay? Now we're going to graph. Okay. Here's the x-axis. Okay. I know. Okay. Yeah. Do take a breath here because
I do need a breath.
we're going to need a breath now. Whew. Okay. So, we're going to create an inequality from 0 to 2 pi. What goes inside? 5x plus pi over 4. Who said that? See, before I could see your mouths move. Thank you, Sammy. Okay. We got to solve this now. This is where you got to be like mathy. Okay? Okay. So first, subtract pi over 4 from everywhere. So I get negative pi over 4 less than or equal to 5x less than or equal to, this is where my little trick with the, loop comes in handy, right? 2 pi minus pi over 4, denominator is going to be a 4. 4 times 2 pi, 8 pi, plus, yeah, plus negative pi, 7 pi over 4. I take that with me everywhere I go. Okay? Yep. I like people are nodding. Okay. Now, divide by 5, which is the same as doing what?
Multiplying by 1/5.
Yes, multiplying by 1/5. By the way, do you see how I'm writing down my steps?
Yes.
I'm not going to give you extra credit for doing it all in your head. So don't do it all in your head. Write things down so you can see them, okay? All right, so negative pi over 20. Oh. 7 pi over 20. So, what's my starting point? Negative pi over 20. Yeah, because it moved over negative pi over 20 from the 0.
Oh.
Huh?
If you know that the phase shift, then you don't need to solve for the side that you know, right?
Right.
So it's positive.
It's all like to check your work basically. The phase shift will possibly be the starting point. Yes. Okay, so this is negative pi over 20, starting point. 1, 2, 3, 4, 7 pi over 20. Now here is where the math comes in, okay? We got to find the other point. So I'm going to color code things here. Okay. This is dead center, okay? How do you find the midpoint of 2 points?
You add and divide.
Oh, there's like a whole thing.
You add and divide by 2. So here's how I do it in my head. This is halfway of negative pi over 20 plus 7 pi over 20. Talk it out, right? Halfway of that and that. It just, because the words then go along with the math. So that's half of 6 pi over 20. Half and 3, I mean, the 2 and the 6 go away, so it's 3 pi over 20.
We need to the other ones too.
Yup. And I'm going to color code it. It's fun.
So then do you just do the midpoint of, of each?
Yep. So the blue is halfway of negative pi over 20 plus 3 pi over 20. That's half of 2 pi over 20. Just pi over 20. The green is half of 3 pi over 20. This is the mathiest it gets. Like, this is the most math, right?
It's just like so fast.
It's just so much fun. 3 pi over 20 plus 7 pi over 20.
I just listen and do like
I can't do that.
This is half of, yep, 10 pi over 20, which eventually is 5 pi over 20.
Wait, can you simplify that?
Fine. Yes, we should.
But it's so nice, like 2, 5, 7.
It's pi over 4. You should. Thank you. That was the hardest part.
Now we're done. Now we'll make the graph.
Now you just have to draw the graph, and that's the easiest part. What's the amplitude? 2. And it's a sine. I mean, it's not a sine from God, it's a sine function, right?
X equals 0, how do we know
Where the y-axis goes. I'm going to talk about that.
Okay.
Yeah. Okay, so look. Oh,
Hello.
Oh.
Bye-bye.
hello. It's somebody from
joining
my.
on the amazing.
Okay, sine starts on the x-axis. It's a positive 2, so it goes up to 0, down to 0. Oh my word. There. That's the graph. Now,
All that for a little.
where would the y-axis have gone?
What?
Yeah, look,
Yeah,
it's
right there.
negative pi over 20, pi over 20. The y-axis would go here,
Oh. Why?
because that's where the 0 would be.
Thanks, man.
Sorry. Okay? Yeah.
I gotta go. Is there a screen test that
Yes. There is, yes. I'm actually making this right here.
Thank you.
Oh, class is over anyway, right?
Class over?
Wait, wouldn't the live be
Yeah.
wouldn't the live be exactly on